topic by topic. We're going to have a look at rates of reactions. We're going to have a look at the effect of temperature on the rate of a reaction. And before we've started here, I've actually gone and prepared a few solutions. What I've got is a little cuvette, and this little cuvette contains about 3 mils of sodium thiosulfate, and it contains 2 mils of water. Well, this is 0.1 molar. And what I'm going to do to this is I'm going to add 1 mil of hydrochloric acid. Now, in a previous experiment we've done this, and this is the one where you might take a conical flask and you put this over an X and you look down here to see how long it takes for this X to disappear. When I did it last time, I used a colorimeter, and that's what I'm going to use this time. So what I've done is I've put 5 samples. The samples I put in are in hot water, and this is at about 40 Celsius. I've put another one in my incubator, and that's set at 30 degrees Celsius. I've got some which is in basically tap water, and that was coming out at about 20 degrees Celsius. I put some in the fridge, which should be at about 10 degrees Celsius, and I put some in the freezer, and I've left it there just for a little while, and hopefully that's going to be between 0 and about 5 degrees Celsius. So I've got myself a range of temperatures, and what we're going to do is we're going to take each of these and I'm going to try to add on 1 centimetre cubed of HCl. We're going to put it into a colorimeter and we're going to see what happens. So I've got my experiment set up already. I've got my colorimeter set up, and I've got my transmittance here, and I've got time. We're going to start with one of these experiments, and I've got my colorimeter ready, and I've got my water ready. My water is in here ready at just about 40 degrees Celsius. Insists on its 40.1, and what I'm going to do is we're going to put it in. I've zeroed the colorimeter before I started, and let's try this with some acid. Now, I haven't put the acid at the same temperature, and this is a little bit of a problem, but it's not easily practical to try and do this, so we're going to have a slight change, but we'll see how we go. So I've got my pipette ready, everything's ready. Let's take out 1 centimetre cubed of acid, and that's ready. Right, I'll take the thermometer out, I can get the stuff out easier then. So there's my tube at the right temperature. Let's take it out this has been at this temperature for about half an hour. Let's squirt the stuff in, put the lid on, shake, put in, and let's start the reaction. And you can see we're nearly complete. And this reaction's just about there now. So it took about 50 seconds to complete, and I'm going to stop that. So there we've got my first one, and I'm going to just tag this, and this is at 50 Celsius, and it is 3 mils of thiosulfate, and we've got plus 2 mils of water. So there I've got my recordings of my experiment. Now what we're going to do is we're going to repeat this experiment, but this time, having done my 40 degrees Celsius, we're now going to do one at 30 degrees Celsius. So let's take this here, this one, out of our oven. It's done, and we're now going to take the next one. So I've got it ready. Let's put the acid in. Here we go. Lid on, shake, put it over. Start the recording. Right, so this one's going. I want to see what the other one is, just so we've got some sort of comparison. So I'm going to have this one go at the same time. Now you can see it didn't quite start at the same place. That's because the reaction, like the other one, was already going, because I couldn't get it in fast enough. But we've got a slight change in the rate. It's slower. So this is at 30 degrees C, and we can see this reaction is going slightly slower. And I think I'm going to stop this reaction now. So here's my second run, and this one was set at 30 Celsius, and again it was the same amount. We had 3 mils of thiosulfate plus 2 mils of water. So we can see here we've got a gradient here, and this is about 4.8. The second run, my gradient for this one, 3.9. So it may not look as much, but there is still a difference. 4.8, 3.9. So now we're going to try the same experiment again, but at 20 degrees Celsius. And what we've got this time, I'll move my sample out of the way, it's complete. Can you put the monitor on for me? What we're going to do for this one is, let's get out my acid. There we are, it's ready. And this one's been sitting in some water, and this water is about 22 centigrade. Let's see what we can do. Put the stuff in, give it a good shake, put it in, and let's start the recorder. I managed to get it in a little bit faster this time, and this one's taking a lot longer to get going. Like a lot longer to get going. And we can see that if we look at the gradient of this already, this is looking considerably slower. 2.3 seems to be about its fastest there. So now we can see this one is at about 2.3. So we've got quite a difference in the gradients already between 50, sorry, it wasn't 50, it was 40, wasn't it? I better go and edit that file. I thought something was wrong. So between 40, 30, and this one is now near, just about done. You can see that the curve's sort of gone, and it's round about that level. So this has taken about 2 minutes this time to go. So let's stop this reaction. And what I'm going to do is I'm going to label this one as well, and this, not the right one. There we are, run 3. So this is in fact 22 Celsius, and again the same amount of 3 mils of thiosulfate plus 2 mils of water. So now we need to try our next one to have a look at, and if I get this one out, you can see it's thoroughly gone, and this one is from the fridge. It feels cold. Going down slowly. I reckon that's going to be about 15. Not quite as cold as I would have liked it, but we'll see what we can do. Putting some of this acid in is going to warm the solution up anyway. And with this one, I am going to just give it a quick wipe over and put it in there. Right, let's have a go. I haven't necessarily hurried as much as possibly I could have. Here, it does seem to be at a different level to start with, and that's probably due to the fact that we are misting up slightly. And that's what I'd expect. But the experiment's now working, it's going down, and we can see that it's really going quite a lot slower here. Remember, it's the rate I'm trying to do, so the fact that that started at a slightly different level than the other one isn't terribly important. And we can see that it's definitely at a much slower rate. Here we're at 1.3. And this is about 15 Celsius, again 2 mils of thiosulfate plus 3 mils of water. And we're gradually terminating. And I think that will probably do for this one. My final experiment I want to have a look at. We've got and I just will show you those two. You can see one has been going on for a few more minutes than the other, how it's gone from white to yellow. Here, this one is blooming cold. Can I have a piece of paper tissue? And I'm going to set this one up. And I think I've actually managed to freeze this one. It was in the freezer for about half an hour. We are just about, now it is okay, we're just about thawed out, so that's just barely above freezing. Let's try this one and see what happens. So let's put it in. Give it a good shake, and let's try this one. So this one's as near a naught as I could get. So set the recorder going. And again we're looking at it misting up. So we really are looking at some sort of misting up here, because we are working at such a cold temperature. And even though I've put it in the container, it's going to start changing temperature a little bit. So let's just see what the rate of this one is going to be. So this one certainly did get this one down to 0. I noticed I'd done that one wrong, so I'll just correct that one because it was there. 3 mils of Thio. And 2 mils of water. I didn't correct. Let's go again. Three mils of Thio and 2 mils of water. And while I'm waiting for this, this one is barely going. It's really struggling to do very much at all. So I think I need to have got my one in the fridge longer. But I've just worked on some temperatures and we can see this one is starting to go. We are seeing some sort of movement here, and we could see that the high temperature ones, the reaction had been completed before this one's even really thought about starting. And if we take this over, we can try and get some sort of measurement, and that's 0.3, 0.4 there. So the greatest rate of this reaction is about 0.4. So let's see what we've got for our rates of reaction, because I can leave that one going. It's not going to get very far. So for our hot water at 40 degrees Celsius, then we're looking at here a rate of about 4.8. The 30 looking at 3.9. Now I didn't manage the 20, I managed the 22 here, and we're looking at that one at a gradient of 2.3. The 10 I didn't manage, I managed 15 here, and the 15 is at 1.3, and then the freezer, I had hoped to get it down just about 0, and I reckon we have got that there. So at about 0.5, then this one is at 0.4. So that's a measure of the gradient, and we can see that this is now just going. It's managed about 0.5 there. That is in fact the fact that it's warming up as well. So we've got some of those things going. So the reaction there is just about complete. I can leave it a few more minutes, but basically we're done, so I can stop that. And if we look at this experiment, you'll see that yes, it has gone, and it is wet on the outside, and that hasn't helped the reaction at all, because the colorimeter is sort of getting sort of a little bit of moisture on there. So we've looked at then putting in 1 ml of acid, but the acid's been at room temperature, and that will have affected all of these rates very slightly. But having said all of that, when we're looking at this, we can see there are definite changes. So this, I'm going to label this graph. This is temperature on the rate of reaction of thiosulfate plus HCl. So having completed that, then I'm going to file, and I'm going to make sure that I save this results, and the reason for that is simply to make sure that I've stored all my results so that I can go back and later analyze what's happened. So there's our graph. Now, what's going on? Can we sort of explain what's going on from this by a thing called collision theory? Let's have a look and see what we can see about this. There's our figures. Now, let's suppose I've got two molecules that are going to react. To get them to react, they are going to need to collide with one another, and if they collide, then we're going to get something happening. But basically, if I increase the speed of the collision, then it's likely to happen faster, because this object will probably arrive at that one quicker, but there will be more collisions because they're going to arrive with more energy. So this has more energy, and that's what temperature is. Temperature is simply the measurement of the amount of energy that molecules have, compared to this one, where it might have got there, but it might not have had enough energy, so there was maybe not enough energy for the reaction to take place. Now, I've done this experiment in the range 0 Celsius to about 40 Celsius. Now, the reason for the range is very simple. If it's basically less than 0 degrees Celsius, then it's going to be a solid. See if I can make that go away for a minute. There we are. I'll talk to him in a minute. If it's less than 0 degrees Celsius, then basically everything is solid. And if they're solid, nothing's going to move and there's going to be no reaction. Greater than 40 degrees C, well, basically now it's too hot to hold. I could probably manage 50 degrees Celsius as my maximum, but if I hold it any more than that, it's going to be too hot to hold and it could in fact damage the equipment. So that's the reason for my choice of temperature. So we get an increased proportion of particles exceeding the energy to try and get my reaction to go. Let's just finish by giving you a little graph. And this graph is about the amount of energy in a system. If we look at the number of molecules, then we get a graph something like this, and this is the amount of energy that they've got, and this is, if we like, the number or proportion. And what we need to get is perhaps this much energy, and I'm going to call this the activation energy, and I'm going to call it EA, energy of activation. And if it's hot, then we would change this graph. So if it's hot, then few molecules have low energy and a lot of molecules will have that energy. So this is when it's hot, and when it's really cold, then we'll have very few molecules with enough energy to get the reaction to go. So this you discover more at A level, but here we can see that this appears to be true. The higher the temperature, the greater the rate of the reaction. And that's what you need to take away from this. Thank you for watching. I hope you found this useful. If you did, please subscribe and give us a thumbs up, and I'll see you next time when we do some more GCSE Chemistry topic by topic. Until then, bye bye.